Hi everyone. Welcome to 5th course of Business Data Analytics. Today we'll talk about Predictive Analytics in Business Data Analysis, a comprehensive course designed for those looking to understand and apply predictive modeling techniques in the business context. This course aims to provide you with a solid foundation in predictive analytics, focusing on linear regression, one of the most fundamental and widely used predictive modeling techniques. Here's an overview of the course content. Today we'll talk about Introduction to Predictive Analytics, with focus on basics of linear regression. We'll understand the concept of model training and testing. So let's delve into the first chapter of today's course, Introduction to Predictive Analytics. We'll touch the following subjects: definition, scope, we'll see some key concepts, and we'll have a look on some use cases. So what is predictive analytics? Predictive analytics represents a specialized field within advanced analytics. It employs a diverse array of methods, including statistical analysis, modeling techniques, data mining, and machine learning, to scrutinize both existing and historical data. The primary aim of this analysis is to forecast future events or identify unknown occurrences. In essence, predictive analytics is the process of utilizing data to make informed predictions about what could occur in the future. This involves interpreting patterns and trends from past and present data to project possible outcomes, thus enabling better decision-making based on data-driven insights. Now let's talk a little bit of the scope of predictive analytics. One of the primary applications of predictive analytics is in the realm of business decision-making. Also, it can be used in risk assessment. In sectors like finance, insurance, and healthcare, predictive analytics plays a key role in assessing risks. Customer relationship management, CRM, to understand customer preferences, behaviors, and buying patterns. Operations management, in optimizing operations, such as forecasting inventory needs, managing supply chains, and planning production schedules based on predicted demands and market trends. Fraud detection and security analysis, by analyzing transaction histories and user behaviors, anomalies that suggest fraud can be identified early. Healthcare, predictive models in healthcare assist in diagnosing diseases early, predicting patient outcomes, and personalizing treatment plans. Policymaking and public services, governments and public service organizations use predictive analytics for urban planning, environmental management, and policymaking. Predictive models can anticipate social trends, environmental impacts, and resource needs, helping to make informed decisions. Advancements in AI and machine learning. The field of predictive analytics is continuously evolving with advancements in AI and machine learning. These technologies enable more sophisticated and accurate predictive models, expanding the scope of what can be predicted and how accurately it can be done. Let's discover some of the key concepts of predictive analytics. These concepts form the backbone of predictive analytics and are essential for anyone delving into this field, whether for academic purposes, professional development, or practical application in business and other areas. 1. Data mining. This involves exploring large datasets to discover patterns, correlations, and anomalies. Data mining is a critical step in predictive analytics, as it helps in identifying the relevant data and insights that form the basis of predictive models. 2. Machine learning, a subset of artificial intelligence that focuses on the development of algorithms and statistical models that enable computers to perform tasks without explicit instructions, but rather by learning from data. Machine learning is integral to predictive analytics, as it involves creating models that can predict future outcomes based on historical data. 3. Forecasting. This is the process of making predictions about the future based on past and present data. It is commonly used in fields like weather forecasting, stock market analysis, and demand forecasting in business. 4. Regression analysis, a statistical method used for estimating the relationships among variables. It's central to predictive analytics, especially in determining how the typical value of a dependent variable changes when any one of the independent variables is varied. 5. Classification. In machine learning and statistics, classification is the process of identifying the category or class to which a new observation belongs, based on a training set of data containing observations whose category membership is known. 6. Overfitting and underfitting. Overfitting occurs when a model is excessively complex and captures the noise in the data rather than the actual pattern, leading to poor predictive performance. Underfitting occurs when a model is too simple to capture the underlying trend in the data. 7. Training set and test set. In predictive modeling, data is split into two sets. The training set is used to build and train the model, while the test set is used to evaluate its accuracy and generalizability. 8. Cross-validation, a technique used to assess how the results of a statistical analysis will generalize to an independent dataset. It is mainly used in settings where the goal is prediction, and one wants to estimate how accurately a predictive model will perform in practice. 9. Decision trees, a decision support tool that uses a tree-like model of decisions and their possible consequences. It's a way to display an algorithm that contains only conditional control statements. 10. Neural networks. Inspired by the structure of the human brain, neural networks are a series of algorithms that capture relationships between various underlying variables and process the data as a human brain would. 11. Anomaly detection, the identification of rare items, events, or observations which raise suspicions by differing significantly from the majority of the data. 12. Predictive model performance metrics. Terms like accuracy, precision, recall, F1 score, mean squared error, MSE, and R squared, which are used to measure the performance of a predictive model. Let's discover together use cases from various sectors of the economy and society. The following case studies highlight the versatility and transformative power of predictive analytics across various sectors. By leveraging data, businesses and organizations can make more informed decisions, optimize operations, and offer better services to their customers. The first use case are related to retail industry. The big retail companies use predictive analytics to identify and segment customers based on their purchasing patterns. By analyzing buying habits, these companies could better optimize their product stock, they could build more targeted marketing campaigns, they can better meet the needs of their customers. 2. Healthcare, predicting patient readmissions. Hospitals have used predictive analytics to reduce readmission rates. By analyzing patient data, including medical history, treatment received, and lifestyle factors, hospitals can identify patients at high risk of readmission and take proactive measures, such as scheduling follow-up appointments or providing additional at-home care instructions. 3. Finance, credit scoring. Financial institutions use predictive analytics for credit scoring, which involves analyzing a customer's credit history, transaction patterns, and other financial behaviors to predict their future creditworthiness. This helps in making informed decisions about lending and managing financial risks. For sports, Moneyball in baseball, popularized by the movie Moneyball, predictive analytics revolutionized player selection and team management in baseball. The Oakland Athletics used statistical analysis to identify undervalued players and build a competitive team, despite having a lower budget compared to other teams. 5. Law enforcement, predictive policing. Police departments, such as the LAPD, have employed predictive analytics to forecast crime. By analyzing crime data and patterns, predictive models can identify potential crime hotspots, allowing law enforcement to allocate resources more effectively and prevent crime proactively. 6. Airlines, dynamic pricing models. Airlines use predictive analytics for dynamic pricing of flight tickets. By analyzing data on travel trends, customer demand, seasonality, and competitor pricing, airlines can adjust their fares in real time to maximize revenue. 7. Manufacturing, predictive maintenance. Companies like Siemens and GE use predictive analytics to anticipate equipment failures in manufacturing plants. By analyzing data from sensors and machinery, they can predict when equipment needs maintenance, reducing downtime and saving costs. 8. E-commerce, personalized recommendations. Amazon and Netflix use predictive analytics to offer personalized product and content recommendations. By analyzing customer behavior, purchase history, and preferences, they can suggest products or content that individual customers are likely to enjoy, enhancing customer experience and boosting sales. 9. Energy sector, load forecasting. Energy companies use predictive analytics for load forecasting, which involves predicting energy demand. This helps in optimizing energy production, managing grid load, and reducing wastage. 10. Automotive, self-driving cars. Companies like Tesla and Waymo are leveraging predictive analytics in the development of autonomous vehicles. These vehicles use data from sensors and historical information to make predictive decisions, such as when to brake or how to navigate traffic, enhancing safety and efficiency. In conclusion, predictive analytics stands as a transformative force in today's data-driven world. By leveraging the power of historical and current data, coupled with advanced analytical techniques, we can forecast future trends and unknown events with remarkable accuracy. This capability is not just a technological advancement, it's a fundamental shift in how we approach decision making across various domains, from business strategy and marketing to healthcare and public policy. The strength of predictive analytics lies in its ability to turn raw data into actionable insights. Whether through simple linear regression models or more complex machine learning algorithms, the goal remains the same: to predict the future more accurately, enabling proactive decision making. As we continue to amass vast amounts of data, the potential of predictive analytics grows exponentially. However, it's important to remember that these tools are not infallible. They require careful application, a thorough understanding of the underlying assumptions, and a consideration of ethical implications, especially in terms of privacy and bias. Embracing predictive analytics means stepping into a future where data not only tells us where we have been but illuminates pathways to where we could go. It empowers organizations, policymakers, and individuals alike to make more informed decisions, anticipate challenges, and seize opportunities that lie ahead. The journey of harnessing the full potential of predictive analytics is ongoing, and its continued evolution promises to reshape the landscapes of industries and societies in profound ways.